Good morning, students. Let's continue with the system testing. In the last lecture, we have discussed the very first type or the parameter of a system testing, that is security testing. What does it mean? What are different elements? Right? How it can be achieved and everything. Now continuing with this security testing, the next one in the sequence is a performance testing. So what do you mean by a performance testing? The performance testing is to test the runtime performance of the software on the basis of various performance parameters. That means the runtime system's performance needs to be evaluated, and that is done with the help of a performance testing. Now, what are those parameters on which this performance testing is carried out? Right. We check the system's performance with respect to memory use, that is, how much storage it is going to use, the response time, how much time it takes to respond, the throughput, how efficiently it is going to perform, and if there any delay or not. So the performance is evaluated on the basis of four parameters, that is memory use, response time, throughput, and delays. Now, what is important here is performance testing becomes important for real time systems because there we have the demand of critical performance requirement. You have to immediately respond within a fraction of second. So you have to avoid or reduce this delay part, and it is definitely there when the system is stressed with or the more load is being increased. So, the system testing requires the performance requirement must be clearly mentioned in the SRS, that is the document that we prepare after the requirement phase, and the system test plan document which is prepared before the system testing. So, since performance is important, what does it mean is related to this performance testing, all the requirements must be there in your SRS document, as well as it must have the proper test plans which includes these parameters. Now, these performance parameters must be quantified. These requirements must be quantified. Quantify का meaning है we need to assign a numerical value. I cannot say the system must perform or it takes less response time. So less is not quantified. It's not give you the specific or the exact time, how much time it is taking to respond. But if I say I want my system to respond within say 1 nanosecond, then it is quantified, right? So all these requirements, the performance requirements must be quantified. You have to give a specific numerical value to each of this so that whatever you specify now that can be tested during the performance testing. Now, what are the set of activities which are required during the performance testing? The very first activity is, first of all, decide whether to use internal or external resources to perform the test, right? Whether all the resources which are present in your development environment is sufficient or you need something else beyond that in order to perform this testing. Once you decide this, internal and external resources, the second one is gather the performance requirement from the users and or business analyst, right? So what are the performance requirement? That is a specification. You need to identify all those. Then develop a high level plan. The high level plan means the plan including the requirement, resources, timeline and milestone. So prepare a project charted for this. Then develop a detailed performance test plan. Detailed performance test plan means you have to identify the small scenarios or the test cases, the workload that we are going to put in, and the environment information that will be created. So that is your detailed performance test plan. Then identify the test tool. Maybe one or multiple tools can be required in order to perform this performance testing. For example, you must have seen that whenever a system is not working properly or it is slow, we open the task manager in the Microsoft Windows, right? In order to check whichever, like you can say the process are running. If it is hanged or it's not performing well, we can end the task from there. So that is related to performance. So you need to identify all those set of tools. Then specify test data needed. That means what will be the information or the data on which you are going to perform this testing. You need to identify or specify that test data. Then develop detailed performance test project plan. Right? Now, what we have to do again, more detailed level of performance test project plan is required that includes minute level details like dependencies and associated timelines. So you must have seen in this we have prepared three plans. One is a high level plan that is for requirement, resource, timeline and milestone. Then we have prepared another detailed performance test plan that is for small scenarios, test cases, workloads and environment information. And further, we prepared more test plans that includes dependencies and associated timelines. Another step is then once you have prepared all these plans and the entire steps are being executed, we need to configure the test environment, right? Configuring the test environment means ideally identical hardware to the production platform simply. What we have to configure? Router configuration, deployment of server instrumentation, database test sets developed, right? So whatever is required to perform the testing that needs to be configured and placed at one location. And finally, we execute the test. Whatever test cases you need to identify, what are the parameters you need to test, the environment, everything needs to be executed properly and get the result. Just summarizing these performance test activities once again. Decide whether to use internal or external resources, then gather the performance requirements, develop the plan, high level plan, detailed plan, identify or choose the test tool, specify the test data needed, then again develop a detailed level project test plan, configure the test environment as per the need, and then execute all the tests in order to perform the performance testing. So this was all about your performance testing. The second category is your load testing. So what do you mean by a load or load testing? When a system is tested with a load that causes it to allocate its resources in maximum amount, it is called load testing. Right? That means you whatever like you are supposed to make a software for 5,000 users simultaneously who can work on it. Normally, what we do, we test for randomly, say 5, 10, 15, hundreds of people, and we carry out this testing. But load testing is since the software is supposed to work for 5,000 users simultaneously, so here we give the maximum load. We allow all the 5,000 users to log in simultaneously on your system and work together, right? In order to check whether the system is going to behaves properly once the maximum load is applicable. So this is what is load testing. Now there is a high probability that the system will fail when put under maximum load. So it is important to test the system with all its limits. This is one particular parameter I'm saying, say number of users. There can be several other parameters also, and you need to check for all those parameters with the maximum load, else if you're not testing it, might be it fails in future. So the purpose is to create an environment more demanding than the application would experience under normal workload. Like normal workload, like for an IRCTC website, is it the normal working days when the we make the reservations. But it's we are talking about load will when the load will increase. The load will increase during say festive seasons or the holidays, summer vacations, winter break, right? So you need to check for that, right? Whether the system is going to work properly. Now during load testing, load is varied from minimum to the maximum level the system can sustain without running out of resources. So it's load testing is not you directly give 5,000 users and you test it. You increase it gradually. First of all, you need to check for the zero, that is a minimum. Then increases gradually, then you can check for hundreds of users, then you can check for 1,000 users, then you can check for 2,000 users, then 3,000, then 4,000, and then 5,000, which is a maximum limit. And check how much system can sustain with that, right? As the load is being increased, transactions may suffer excessive delay, right? So gradually you're checking how much it can sustain. Say it can sustain till 3,000. Beyond that, your system goes slow since there is a delay because a number of requests increases, so the systems become slow due to this delay factor. Say when many users work simultaneously on a web server, the server responds slow. So in this way, through load testing, we are able to determine the maximum sustainable load the system can handle. So this is what about load testing is. Another one is a stress testing. Now, the name load and stress testing means almost similar. Then what is the difference? Why we are categorizing them as two different parameters? Load testing was to check for the maximum load for which the system is developed, while stress testing is to check beyond the limit, that is more than 5,000. It might happen sometimes, okay, like during the festive seasons as well as Tatkalas. The number of users can be more beyond our expectation. So how the system is going to behave, whether it will go slow or it is going to crash. So you need to check for that stress, how it can handle that stress. Thus stress testing tries to break the system under test by overwhelming its resources in order to find the circumstances under which it will crash. So we need to identify what all will be the parameters if given beyond a certain limit, it will lead to the failure or the crash of the system. Now the areas that may be stressed, right? Which all things can be stressed is the input transactions, that number of transactions can be increased, disk space, outputs, communications, and interaction with the users, right? So this is what the areas where we can increase or we can put more stress in the system and check whether the system is going to crash or it is going to work well with these. Now take an example. Many of the defense systems which are real time in nature demand the system to perform continuously in warfare. It's not that it must perform for a day or few hours or few days. Continuously work can go for unlimited time. So it must work throughout, right? And it must give a real time response also. Thus, for a real time defense system, we must stress test the system. Otherwise, there may be loss of equipment as well as the life also. So see how important it is to perform a stress testing. Else it could be life critical as well. Now, the another type is a usability testing. So, as the name suggests, usability is how much user friendly your system is. You need to test for all those parameters. Are able to use users able to use it properly, right? So, usability testing identifies the discrepancies between the user interface of the product and the human engineering requirement of its potential users. So the difference or the discrepancy between the interface or the say browser is an interface, right? And the user's requirement, how the user want to use it. The goal of usability testing is to verify that intended users of the system are able to interact properly with the system while having a positive and convenient experience, right? It's not that you are able to use the system, you must use it, and the flow or the sequence, like it navigates to another pages, you need to click it, everything works smoothly and you're having a very convenient experience in that case. So this is what needs to be tested using the usability testing. Now, what does it focus on? System testing. This type of system testing, that is usability testing, is related to the system's presentation. How well you have presented it so that user can use it properly rather than its functionality. An effective tool in the development of a usable application is the user interface prototype. So the tool used is a user interface prototype. This kind of prototype allows interaction between potential users, requirement personnel, and developers to determine the best approach to the system's interface. So simply a tool, that is a prototyping tool for interface. Now, how you can gather the usability requirement? How come you know what user expects? Right, what all features should be present in your like you can say the page you are developing so that they can interact it well and give a positive response, right? So you can get the information from the area experts who are working on similar type of projects and they have an experience. You can conduct a group meeting among the users to get their requirement. You can carry out the survey in which you interact with the users and get their valuable information and analyze similar kind of products, right? Say you are developing one product, say for mm, library management system for graphic error, right? So there must be other similar kind of product like library automation system for some other institutes or university. You can check that, and accordingly you can fetch the usability requirement, how well they are being developed, and accordingly you can get the requirement for your project. So these are the four like areas from where you can gather the information from the area experts, from the group meeting conducted among the users, from the survey you carried out, and analyze the similar product so you can get the usability requirement, and then finally you can implement and test it. Now, what are the characteristics of the usability? First of all, it must be easy to use. That is ease of use. You can the user can enter, navigate, and exit with relative cases. That means entering the information is also easy. Navigating from one link to another is also easy. And once the end task is end, the exit is also easy. So you need to get this first thing. Characteristics is easy. Second one is interface type. User interface type should not be misleading. Say I click on a particular button. Say it must navigate me to a student information page. But mistakenly it takes me to employee information page. So this must not be there. The interface or the navigation must be proper. It must lead to the proper page whichever is requested. It must not be misleading. Then the response time. The time taken in responding to the user should not be so high that the user is frustrated or will move to some other option in the interface. The response time or the delay must be less. Then help system. A good user interface provides help to the user at every step. That pop-up comes in, now do this and this. Or you have a help documentation or a menu and you can check it from there how well you can use a particular system, right? It makes the system easy to understand in a most precise way. Then the error messages. For every exception in the system, there must be an error message in text form so that the user can understand what has happened in the system. Error messages should be clear and meaningful. So definitely everything is not perfect, the errors will be there. But you must know what exactly is the error. Say I was working with my system and some error has occurred. Until unless I know what is the error, I cannot search it in the Google and get the information what is this error and how to resolve it. So this is important for each and every application to display exactly what is the error, right? That is important. So quickly revising, what are the characteristics? First of all, ease of use. Then interface steps must not be leading. It must have a proper response time accurate. Delay must be less. Then you must provide with the help system or the documentation and error messages will be displayed. So if all these characteristics are present, we can say yes, you can have a proper usability testing needs to be carried based on this. Now the last one, that is compatibility, conversion or configuration testing. More or less they are similar. Compatibility testing is to check the compatibility of the system being developed with different operating systems, hardware and software configurations available. So whether are they like compatible or not, the OS, hardware and the software configuration, they must work properly, right? Now, what is configuration testing then? Allow developers or the tester to evaluate system performance and availability when hardware exchanges and the reconfiguration occurs. Right? So, when there is a change in the hardware or you are reconfiguring your system, then you need to check whether it is working properly or not. So, that is configuration testing. Compatibility for OS hardware and software, while configuration is for hardware exchanges and reconfigurations. Now, there are few guidelines for compatibility testing. The first one is operating system. The specification must state all the targeted end user OS on which the system being developed will run. So you must have seen whenever we develop the software, we specify the hardware and the software on which the system is going to work, the minimum configuration, right? So this is what I said, on which all operating systems the target system is going to work, that should be listed down, right? Then the software and the hardware. The product may need to operate with certain versions of web browsers, with hardware devices such as printer, or with other software such as virus scanner or word processor. So you need to specify all those hardware and software requirements which are compatible enough. Then conversion testing. Compatibility may also extend to upgrade from previous versions of the software, right? Therefore, in this case, the system must be upgraded properly, and all the data and information from the previous version should be also be considered, right? You're converting from one version to another, so the previous data you need to fetch it from the previous version, right? And it must be properly done. This is what is checked in conversion testing. Then ranking of possible configuration. Since there will be a large set of possible configurations and compatibility concerns, the tester must rank the possible configuration in order from the most to the least common for the target system. Most compatible one, right? You'll rank 1. Moderate one, say you'll rank 2. And the least compatible one, you are going to rank 3. So you can scale it, right? From most to the least one, ranking of the possible configuration. Then identification of the test cases. Testers must identify appropriate test cases and data for compatibility testing, right? This is okay, fine. You need to identify all those test cases. Now, updating the compatibility test cases. Now, we know that the system keeps on upgrading, right? You are making changes, new versions comes in, so you have to update your test cases also, right? So, quickly revising again, the guidelines for the compatibility testing, you need to specify all the OS, you need to specify all the hardware and software configuration, then conversion testing, when you're moving from one version to the another, then you have to rank all the possible configuration from most to the least common, then identify the test cases and continuously keep on updating these test cases. So this is what is meant by usability testing. So that's all for today. Thank you.